So when I see this radical function, the first thing I want to do is identify the vertex. Make sure you show me work, okay? It's the point -2, -1. So remember what I'm doing is I'm looking for the opposite of -2. So I'm really looking at +2. So +2, +2. So +2, +2, +2, +2, check. And then -1, remember when it's the vertical translation, it's a straight shooter. So -1, -1, +1, +1. So that leaves me with two functions. So how do I know which function it is? So at this point, what I'm going to do is I'm going to pick another point where it crisscrosses. And I just pick 2, 1. And what I'm going to do is I'm going to put 2 in for x, and I'm going to put 1 in for y. 2 in for x, and 1 in for y. And I'm going to simplify and see if it works. So 2 plus 2 is 4. The square root of 4 is 2. 2 minus 1, does that equal 1? It does. But let me double check. 2 plus 2 is 4. The square root of 4 is 2. Times 2 is 4 minus 1. Does that equal 1? It does not. Notice how I'm showing my work. You got to show me work. I don't want to think that you're guessing. Okay, so I'm going to solve this one first. I'm going to add 9. I cannot get rid of the radical until I just have a radical on that side. Now that I just have a radical on that side, I'll square both sides. Let me get my blue pen. I always do it in blue. Squared, squared. So that eliminates the radical. 3r minus 6. 6 squared is 36. Add 6. Divide by 3. Okay. Now what I want to do is make sure that it's actually something that works. So I'm going to plug 14 in. So 3 times 14 is 42. 42 minus 6 is 36. The square root of 36 is 6. And 6 minus 9, does that equal -3? It does. So that actually works. Let's try this one. Subtract 9, subtract 9. Square root of 3r minus 6 equals -12. Now that I'm just left with a radical, square. 3r minus 6 equals 144. Add 6, 150. Divide by 3, 50. Now what I need to do is plug this in. So I'm going to plug in 50. So 3 times 50 is 150. Minus 6 is 144. The square root of 144 is 12. Does 12 plus 9 equal -3? It does not, so this is the one that's extraneous. You don't have to show me every little step of work, but show me this to show me which one's extraneous, if any are extraneous at all. Maybe both of them are extraneous solutions. So be careful of things like that. Okay? Let's go to the next one. So the first thing I'm going to do is get rid of this -5. Now if I'm dividing by 5, I'm really multiplying by the reciprocal. And then on the left side, I'd be left with x to the, it looks like it says -3/2 equals 5 on top, 5 on bottom, gone. A negative and a negative make a positive. So I'm left with 1/27. Let me zoom that in a little bit. Now as soon as I see a negative and I see a fraction, I'm going to make this be negative as well. 1/27 is the same thing as 1/3 cubed. So if I rewrite this, this is the same thing as 3 to the -3 power. So first thing I'm going to want to do is get rid of the negative exponent. So I'm going to multiply by -1/3. And when I do that, a negative and a negative make a positive. That cancels, and I'm just left with 3 on the right. A negative and a negative make a positive. That's gone, and it's x to the 1/2. I am not going to be okay with you just multiplying by the reciprocal because that's just a trick. I want you to understand what you're doing step by step. Now, the way to get rid of 1/2 is take the inverse, which is squaring it. And that's gone now. X equals 9. Okay. If I have a lot of time on my hands, I could check it. You know what? Actually, let me check it just so you can see. So I'm going to take this problem and I'm going to check it. -5, parentheses, 9 to the -3/2. And I want to see if it equals -5. Let me move that up. Over 27. So I know that 9 is the same thing as 3 squared to the -3/2. So the squared's gone. So -5, 3 to the -3. 3 to the -3 means it's really -5 times 1/3 cubed. And 3 cubed is 27. -5/27. Boom, I did it right. Okay? let's go to the next one. I'm going to square it. Now be careful when you square it, because although on the left side everything cancels, on the right you have the 5 on the outside. So you have to square that, then this squared eliminates this radical, hence a parentheses. Distribute. Small x to big X, even though it's the bigger X, but you can't move this, so you're left with nothing. Divide by negative 21. A negative and a negative make a positive. I know that those numbers divide by 3, and that's 50 over 7. I'll show you in your calculator. Let's see if the calculator will help me a little bit. So I'm going to go 150 divided by 21, and it gives me a decimal, which you cannot do. But I think there's this button here where it's blue. See how the blue part? So you're going to go, let's see. Nope, that's not it. Let's see. So 150 divided by 21. Nope. Okay. I know there's a way. So obviously I'm not figuring it out. Nope. Okay. I can't figure it out. But what I can do is this. 50 divided by 7. I know there's a way. So someone will figure it out. It's the same decimal approximation, so I'm good to go. X equals, let me make sure I don't plug in that. So I could just plug it in and hope that it works, and it does. All right. Let's go to the next one. Square it. The square eliminates the left. On the right, I box it out. X minus 4, x minus 4, which is x squared minus 8x plus 16. Now, whenever I have a squared, I set it equal to 0. So do the opposite. I'm left with x squared minus 9x plus 18, x minus 7, x minus 2, x equals 7, x equals 2. Now, what you want to make sure you're doing now is checking for extraneous solutions. So, when I plug in, let's see, did I do that right? I think so. When I plug in 2 minus 2, I feel like I might have done something wrong here. I didn't do anything wrong. When I plug it in, 7 minus 2 is 5. Let me pause it real quick. I think I must have made a mistake. Okay, so I went a little bit fast, and I want you to be careful, and I want you to see how I knew I made a mistake. Because the 7 minus 2 is 5, and the square root of 5 is the square root of 5. But then if I go 7 minus 4, that's 3. That's like not even a little bit equal. And the reason is I went a little bit fast, because when I add 7 and 2, I get 9. But when I multiply, I get 14. So I was silly, and my numbers are 6 and 3. It's funny, I did that on the practice, and I did it now. So let's try that again, 6 and 3. Now, 6 minus 2 is 4. The square root of 4 is 2. And 6 minus 4 is 2. You can see they're similar. Boom, it works. 3 minus 2 is 1. The square root of 1 is 1. 3 minus 4 is negative 1. I know that because one's positive, one's negative, that I was on the right track. So I'm good to go. Let's go to the next one. Can you do me a favor and make this a 2 and make that a 3? There's a mistake in there. Okay? When you do this problem, you can't even acknowledge this right here until you get rid of the 3 and the 5. This reminds me of a problem like this. If I had 238 equals 3x minus 5, you would add 5 and divide by 3. That's what I'm going to do here. Add 5. And now I'm going to divide by 3. 3 goes into 24 8 times. 3 goes into 3 1. Okay. Now what I'm going to do is I have options. I look at 81. When I think about 81, 81 is 9 squared, and it's also 3 to the 4th. Honestly, it doesn't matter which one you do, but the reason I would pick 9 squared is because this 2 matches that 2 on top. I could still do 3 to the 4th and get the exact same answer, so don't worry, you'll be fine if you do that. Okay? But that's my choice. So I'm going to go 9 squared equals x minus 14 to the 2/3. First thing I want to do, get rid of the squared, so I'm going to take it to the 1/2. Now that's gone. That's my point. 2 on top, 2 on bottom, gone. X minus 14 to the 1/3. Now, since I have it to the 1/3, what am I going to do? I'm going to cube it. And 9 cubed is 729. If you didn't know that, your calculator will tell you that. Gone. And then I add 14. And I get 7x equals 743. Now, when you're done with this test, plug it in. Go 7 minus 14. So let me show you. So I'm going to take the answer, 743, and I'm going to subtract 14. Okay? So I get 729. I'm going to take that answer, parentheses, to the 2/3. Then I'm going to multiply it by 3. And then I'm going to subtract 5. And I got 238, and there's the other side. Okay? So you can definitely check it. All right, this problem is actually a little bit, to me, more simplistic than this one. This one was a little bit crazy. But let's see how it goes. So I'm going to take this. I see that 4 is the same thing as 2 squared, but 2 squared with the 5 isn't going to do anything for me. So I'm just going to leave it. Now, you could write it as 2 squared and then take it to the 5th power, but I just don't want to do that. So I'm going to take it to the 5th. And I'm left with 2x plus 8 equals, and I'm going to go on my calculator, 4 to the 5th. Oops, delete. And it tells me 1024. I didn't have that one memorized. Subtract 8. 2x equals 1016. Divide by 2. X equals, goes into it 5 times, goes into it 0 times, and 16 is 8. X equals 508. So now let's check it. Okay, so I'm going to go 2 times 508 plus 8. So 2 times 508 plus 8. And they're telling me to take it to the 1/5 power. And I got 4, and that's what I was supposed to get, so I know that I did it right. Okay? All right, let's see. Tell me everything you can about the given function. All right, let's start off with what I know. This 6 means horizontal translation, 6 units left. This will probably be a big old multiple choice question. So make sure you show work. This is telling me a vertical translation, 4 units down, straight shooter. But this is also vertical, so it's telling me a vertical stretch by a factor of 4. I should have written, but whatever. Okay. All right, let's fake graph it. If I was to fake graph this, this would be the point -6, -4. So if I look at the domain starts at -6 and goes to the right. Therefore, the domain here is that x is greater than or equal to -6. Or I can write it as included -6, positive infinity. My range is it's starting at -4 and going up. So that means my range, I realized you can't see that, sorry about that, is y is greater than or equal to -4. -4, positive infinity. My vertex is -6, -4. There's my vertex. End behavior. Okay, I notice that it's going up. It's a positive end behavior. If I'm talking about equivalence, I could rewrite this as g of x equals 3. And instead of writing it in rad form, I could write it in exponential form. So that would be equivalence. And the transformations I stated here. And there's the parent function. So I feel like that covers everything. So I didn't write positive end behavior. Okay. All right. Describe the transformation based on the parent graph. Remember what's in here. This is like -1 times x plus 3. That's what it really is. Because this would be horizontal translation 3 units right. But this negative reflection means that it affects your translation. So now this is a horizontal translation 3 units left. But you have to write it in words. If you write HT3UL, I don't know what that means. And then this is telling you it's a reflection over. Since it's with the x, the reflection is actually with the y, because reflection is the opposite. And this is a vertical translation, straight shooter, 8 units up. Okay? All right. Now it's telling me to create a function. So I know when I create a function, I start with f of x, g of x, h of x, whatever. It tells me it's a 4th root function.